All right, so here we're talking about a rectangle door in problem number 4. We're talking about writing a radical expression, and we're talking about a rectangle door in a museum. And we know that this door here is 3 times the width, okay? So 3 times as tall as it is wide. So, and we want to know what the simplified expression for the maximum length of the painting that fits through the door. We know that the door is W units wide, and it's 3W units high. We need to know the diagonal length, so that's going to be our hypotenuse of the doorway. So we're going to use Pythagorean Theorem. So now we're not going to be able to completely simplify this just because we don't have any actual set numbers. So we're just talking about this as something in terms of how to set up our equation, all right? So we know that we're going to have a squared plus b squared is equal to c squared. But let's talk about using this in terms of length and width. So our length is going to be, our hypotenuse is going to be d, all right? So let's say d squared is going to be equal to w squared plus our length squared, okay? Well, in terms of this problem here, we have, let me go a little bit smaller on my pen. Okay, so let me rewrite this higher up. So we have d squared is equal to w squared plus l squared. But we said that our length is 3 times the width. So let's rewrite this as d squared is equal to w squared plus our length, we're going to plug that in, 3w squared. Now, and we're using Pythagorean Theorem. This is Pythagorean Theorem. And I'm going to use abbreviation, THM for abbreviation. Now I'm going to simplify, and I'm going to distribute. Again, our rules of exponents say that exponent outside the parentheses need to be distributed to all of the terms inside the parentheses. So I'm going to rewrite this as d squared is equal to w squared plus, that's going to be 9w squared because 3 squared is equal to 9. Now I can combine like terms. So this is going to give me, so when I'm adding to, the bases are the same and the exponents are the same. So I can just add these and I can essentially say that there's a 1 in front. So then this is going to give me d squared is equal to 10w squared. All right. Now I'm going to take the square root of both sides. So this is going to be the square root of d squared and 10w squared. And so I'm going to say d is equal to, let's talk about this. So if I say take the square root of both, so let me write this over here. So I take the square root of 10 times the square root of w2. Okay, these are our rules of taking the radical of something. 10, the square root of 10, I can't simplify that further because we know that and we're using the multiplication properties of square roots. Because there's no perfect square, I have my perfect square less than 10 would be 4 and 9 and 1. All right, 9 won't go into 10 evenly, and neither will 4, and 1 will go into 10, but then that would just leave us with 1 times 10, so that doesn't really work. So, but I have here w squared. Now remember, if I take if I take w squared, and I'm going to rewrite the square root of w squared to a fractional exponent. When I take a power to a power, I have to use my rules of multiplication. So that's going to be 2 times 1/2. So then that's going to be 2 over 2, which gives me w to the power of 1. So when I take the square root of w to the power of 2, the radical sign and the 2 cancel each other out, so then I'm just left with w. Then I can take keep the square root of 10, because that won't reduce any further. So now, in order for me to talk about that, then my that length, the maximum length, so an expression for the maximum length of the painting, because we want to see what possible maximum possible length of the painting that we could fit through the door would be W square root of 10, or we can say square root of 10 reduces to about 3.16 width-wise. So 3.6 times the width. So, and this is actually pretty handy for us to use because we can find the measurements for the door, and we can find the measurements of the painting, and we can know whether or not the painting will fit through the door. But that is our final answer, and we are done. Let's see. Yeah, I'm not going to do any of these example problems. I think that you're pretty good. If you do need some help on these, let me know, and I will gladly do another video. But I think you pretty much get the gist of the idea for Pythagorean Theorem and how to use them, and you can answer these problems, the sample problems on your own. See you later. In the next video, I'm going to start talking about Chapter 7. See you then.